Beautiful PowerPoint slide. Yes? No? Okay. So Terraform, basically what we're talking about tonight is infrastructure as code. So this on AWS, which is a platform I'm most familiar with, they have their own cloud formation tool. Terraform is a third-party tool that covers a whole bunch of different providers, not just AWS, but that's what we'll be looking at tonight. A little bit about myself. I've been a solutions architect for about 20 years now. I stepped out of the IT world full-time about 10 years ago and got into the precious metals industry when I was living back in Australia. Created the business there. We recently exited that last year, which took up a considerable amount of time, which is why Rumple never got off the ground, even though I've been working on it. But the idea of Rumple is a platform for trading precious metals here in the US. Experience very similar to what you might get if you're doing Robinhood, for example. It's an industry populated by a lot of clicks and mortar type businesses, and their idea of innovation is usually putting WooCommerce onto WordPress. So we're looking at a platform that we've built from the ground up, and it's all built on AWS, a lot of microservices, and it's a nice, quite fast platform. And we are hopefully only a few weeks away from launch after working on this for about 2 years now. So one of the things that came with that is a whole bunch of orchestration requirements in terms of how we manage our infrastructure. So some of the components we use, we've got Lambda functions, Elasticache, RDS databases, GraphQL schemas. There's React applications to be deployed on top of that. And it became quite onerous to try and hold a lot of that sort of, we're very small, there's only 2 of us involved technically. A lot of stuff to try and hold in your head without proper documentation in terms of what have we built, and then you got to create that in dev, got to create that in staging, got to create that in production. So the usual problem, how do you manage your infrastructure when core competencies might lie with business roles or coding, for example. So looking around, trying to find out what's a good tool that would allow us to manage the infrastructure and also treat it a bit more rigorously, like infrastructure as code is essentially what we're talking about here. So how do you maintain the state of your stack and know that we need to make these changes, and how do you make the changes in development and then roll them through to staging and production and tests and things like that. So luckily Rumple started with the Greenfields architecture, so we got to build everything from scratch. Initially when we started building this project out, it was all handcrafted through the console. So creating your VPCs, setting them up, all your security groups, your network interfaces, all that sort of stuff was all sort of handcrafted. And then when you go to create your staging environment, it's like, how do we do it in dev? Why doesn't this work? Why can't I see my database in this environment, but I can see it in that environment? So that's where the use of a tool like Terraform comes in really handy for being able to manage that orchestration, especially across multiple environments. And of course, rumple.io, that's us. If you go there right now, you can put your email address in. So if you're interested in some metal to your portfolio, check us out. So there's 2 aspects of what Terraform does for you. There's orchestration and there's management. Orchestration is, how do we create and provision infrastructure in the first instance, like the first time we need to turn it on. Management is the ongoing management of that infrastructure. Like, okay, we have EC2 instances or something, or Lambda functions. We need to change, the number of, change the amount of RAM, for example, that's been allocated to a machine, or some other changes like that. So there's 2 parts to Rumple. Two parts to Terraform. Like, we'll look at the orchestration as to how you can create your infrastructure through there, and then also what are some of the workflows that you might experience, like from a management perspective, once you've got it all set up, which is actually, it is a considerable amount of work to do that for a large environment. How do you then, put that into like your CI/CD processes and things like that, and make it part of your workflow or your DevOps practices? But I guess the real takeaway, if you've never encountered infrastructure as code before, you're no longer managing your infrastructure through like the CLI or through a console. You really are managing it as configurations. They can be checked into version control, treat the configuration like code, and you can apply workflows to it. So I spoke about Terraform a little bit. Hashicorp is a corporation that puts it out. It is free to use. There is an enterprise version as well, but the free tooling that they have out there is actually quite substantial, and it does everything that we need to do with it. One of the things that you get with the enterprise version, for example, is you can do predictive pricing. Like, okay, if I deploy this configuration I've created, what's the likely impact going to be to my AWS bill? Like, am I turning on something that's going to cost me $20 a month, or am I turning on something that's going to cost me $20,000 a month? There's also a lot more team management in the enterprise version, so you can have like teams of you know, your DevOps team, your just straight developers. People can have permissions in development environments, but not in the production environment. So you can, you know, do some you know, the least access of the principle of only allowing people access to what they need to use. So you can't have a developer inadvertently blow away production infrastructure if they don't have authority to see that. The way that Terraform manages your infrastructure is through a concept called state. So we have a configuration which models what the infrastructure is either orchestrating or managing. And then there's a state, which is like a local representation of this is what we believe is currently deployed into the environment. And it uses this state to determine changes that you made. So you might be changing, for example, we talked about memory allocation to an EC2 instance. When you go to do a run, it looks at what the configuration is. You might have taken something from 4 to 8 gigabytes. It looks at the state and says, oh, this is 4, but the configuration now says 8. And you can plan these changes out, and it will recognize that, hey, we need to make this change. We're going to make this here. Do you wish to proceed or not? And you can, you know, choose to execute or abandon that change to your infrastructure. And then using stuff like GitHub or other repositories, you can then, you know, do those changes on branches. You can check them in. You can propagate them through. And when we get to the end of the PowerPoint slides, we'll actually walk through a real demonstration of taking some existing infrastructure that's already on AWS, and we're going to bring it into Terraform, like import it. We're going to create states for it, and then we're going to take that state and actually export it from our local machines, and we put it onto the Terraform Cloud platform. So you have the choice of running this locally or on a cloud platform that Terraform provide. So a couple of important concepts to understand in terms of how Terraform builds all this stuff. The first one, I guess, is providers. Like, so we have not just AWS, but there's Alibaba Cloud, Google Cloud Platform, Azure, you know, DigitalOcean, you know, there's a whole bunch of different services out there. And it also covers, you know, you can do, it even looks into things like Cloudflare. You can manage Cloudflare configuration through it. So a provider is essentially the module that allows the Terraform platform to talk to your host provider. So, you know, it manages the infrastructure API that particular vendor has implemented, and it's the bridge between like AWS and Terraform, or the bridge between Azure and Terraform. So depending on which environment you're working within, you'll need to have a provider set up for that particular platform. And it really is quite simple. Usually it's just a case of declaring what your credentials are, roles, if you're doing things like IAM access. And on the next screen, we'll actually see how simple those provider implementations are from a end user perspective. One of the things that I like about IAM with AWS is that you can create a role inside of an account, and then Terraform can assume that role. So there's no actual Terraform user single account, and you can say, okay, we need Terraform to manage these 4 different accounts in our AWS organization. You can create a role in each of those accounts and add that to a group in your master account for AWS organizations, and then you just pass the role that you want to Terraform when you're executing, and Terraform can then access the specific environment that you want to be deploying or managing infrastructure within. So on this next screen here, these are 2 examples of providers. So the top one is what a provider might look like if you're just doing it locally, and it's using Terraform. There is a language that they have. I've forgotten the name momentarily, but basically like a Terraform scripting language, a little bit similar to JSON. And the top provider block that we're looking at here is one that you might have if you're running it locally on your machine. So, you know, you pass it an access and secret key that you get from your AWS account, the region that you want, and the role that you want Terraform to assume while interacting with Amazon on your behalf. The bottom provider there, which has got a lot of those credentials stripped out of it, is what it might look like if you're using Terraform Cloud to be running your infrastructure instead, because we'd set the key, region, secret, things like that up as environment variables instead. One of the big things to make sure that you don't do always is don't check your private keys into GitHub, for example. So the top provider block there uses your secret key to log in. So you want to have provider in your ignore file if you're going to be managing this sort of stuff locally. And this is one of the reasons we've actually moved from the local version of it to the cloud version. There's other benefits besides that, but one of them is to make sure that you're never in a position where you would accidentally commit your AWS secrets to a repository. If the repositories are private, that's just not the sort of thing you want to have floating around in the wrong location. But essentially, if you can see with my mouse, can you see my mouse moving on the screen? Anyone? Yep, good. Okay, so up here you can see there's the credentials in the region, and obviously they're missing from down here below. This is where we pull them in from the environment variables instead. So yeah, so on to orchestration and configuration. So we've got a provider set up. We can talk to AWS now from Terraform. What are we managing? We're managing some code. What's the code? It's going to be a resource definition for the most part. Resource definitions might live within modules. So there's a hierarchical structure that we set up here to manage our infrastructure. TF is the file extension. So a Terraform file is basically just a TF file. It might say, okay, I'm an AWS S3 bucket. This is my name, and these are my attributes. And that's essentially coded into a resource block. And that's what they call a definition. Those definitions allow us to orchestrate the creation of that infrastructure and the ongoing management of it. For example, if you had an S3 bucket defined, you might want to enable versioning later. So you change the attributes of that definition that control whether versioning is turned on or off in that bucket, and push it through your workflow, and then your bucket over in AWS would now have versioning enabled. There's a few learning curves that you need to go through in doing this. For example, security groups. If you want to change something in security group, Amazon wants to blow that security group away and recreate it. And if that security group is already being used by a whole bunch of different artifacts, it just can get a bit gnarly. So there's a few, I think security groups are the absolute worst thing to be managing in Terraform, just from a constraints from the Amazon side in terms of how security groups work. So that's one thing you really want to get right first time with your security groups. It's just a learning. When you have these resources defined though, one of the things you can do is create modules. So for example, I usually create modules for my Lambda functions. All my Lambda functions are related to like this specific GraphQL interface. I have a bunch of Lambda functions that act as resolvers to that GraphQL. So I'll put all the Lambdas into one module. Then I'll have another module that handles all the like the mappings of templates and things like that, but to link those resolvers to the GraphQL functionality. That allows you to also, the same concept allows you to also create like a library of infrastructure. For example, say you had a standard S3 bucket that was like, security had looked at it and said, yep, this meets all the corporate policies, it's not public, people can't write to it, no one can access it unintentionally. You could create an S3 module that you check in as a library artifact. And then when somebody is assembling new infrastructure, like, okay, we have a new website going up for something, and we need to use an S3 bucket for it. You can grab from your library, here's an existing definition for an S3 bucket that has been through quality control and we know won't, expose our customers' data on the web. So modules allow you to start doing, reuse of code. So not reusing infrastructure, but you're reusing the configuration of that infrastructure without having to manually handcraft and recreate it each time. Now, modules also take inputs, create and have outputs. So you might have a dependency in a module from another one. So this module needs to know about what's the VPC that it's going to be running the artifacts in. So it can take that as an input, and it might have, say you're creating a queue, for example, a messaging queue. You can export the value of the queue or the identity of that queue so that other modules can then pick that up and say, okay, I'm going to subscribe to this queue now. So you get a module, take a variable in, and you can pass out just the attributes that you want to expose to other modules. Is that you have quite granular control over what you choose to surface through those or not. And here's an example right now of a security group, for example. And this is an AWS security group. So we have the resource type is AWS security group. Terraform's got some of the best documentation I've ever seen from a provider of any software. So you can go through and you can look up, what an AWS security group is, what are all the attributes of it, what are all the outputs it creates. Here's a couple of different examples of it. It's really detailed. So in this example here, the resource type is an AWS security group. Outbound is just the name I've given to it. So if I had two different security groups, one might be outbound, one might be database, for example. I can give details here what it is. I'm pulling in a variable, which is like the ID that the VPC will be running in. I'm defining my ingress and my egress. So in this one, this is just letting all traffic get out of the VPC while keeping it firewalled from anything coming in. And down the bottom, we can put some tags. I like to tag everything that I manage through Terraform, the Terraform tag. These are totally freeform, what you put here. And I actually have modified this a little bit now. Instead of having like a hard-coded repository name there, I pass in a environment variable so that when I'm looking through the console, if I do go back into the console, I'm looking at this security group, I can see, okay, it's managed in Terraform, but not only is it managed in Terraform, but this is the repository in GitHub that manages this particular definition of where it lives, so I know where to look at to find that. And we can see here, you pass the variable in, the ID of the VPC, and you pass an output, which is the ID of the security group, because this security group ID is used everywhere throughout AWS when you're managing assets in your virtual private cloud. So that's an example of the Terraform syntax and defining a resource, passing variables to it, taking outputs from it. Now, state is how Terraform keeps track of those resources that have been defined and actually implemented or imported even. It's just a big JSON file. It's quite verbose. So for example, that security group, the state would actually reflect a whole bunch more information in there than just what you defined. There might be a whole bunch of default values, for example, that a security group has, and there'll be relationships with okay, what are the network interfaces that are attached to that security group? All of that information is recorded in the state file, and that's going to be either locally on your machine, that state file. You can host it remotely in like an S3 bucket, which allows teams to use the same state file, so you don't have different developers all trying to maintain their own version of the state with the same infrastructure. Or you can use the Terraform Cloud to be managing that state. And I did mention this earlier, that when you change your definition, so you either got a new definition or you modify it, like you change RAM from 4 to 8 gigabytes. When you plan that implementation, Terraform checks your new definition against the state, identifies the differences, and it'll tell you what the proposed changes are. And I need to create a resource, change a resource, or destroy a resource in order to execute that. And when you do that planning, you can also, there's nothing to stop you literally executing 100 resources at once. And, if you have a infrastructure architecture that allows you to do that, you create the entire thing in one go, all your definitions at once will run through, and each of those will be added to the state as a process. And then in the future, you just need to make little incremental changes. And we talked before about where the state can live. I started our journey doing Terraform locally just as I need to learn this product. Let's try it out. Installed it on my machines, just a simple exe on Windows. But the state lives on your machine. You don't want to check the state into source control because your state might contain secrets that you exposed. And it only works for one person. If I had somebody sitting here next to me working, they couldn't use the state that's on my machine to manage the same infrastructure. So you can look at doing a remote state, which is okay. We still run everything locally on machines, but the state will go and live in an S3 bucket somewhere. And then you can do a bit of management of who's updating the state at the moment, one person or the other. Where we've reached now is Terraform Cloud, which is where we take Terraform off our laptop. We basically do, funnily enough, the purpose of Terraform is to stop using the console at AWS. So now we use console at Terraform to manage AWS. So you do everything through the console over there. You have a concept of organizations and workspaces. There's a one state per workspace. So For example, our development environment for Rumple, I think, is actually 13 different workspaces in the cloud. One workspace manages the VPC, one manages the database, one manages Cognito user directory, another one manages each of our GraphQLs, one manages all of our messaging queues. So that when we do update state, we're only affecting, like, a small part of our infrastructure. We aren't accidentally applying a state somewhere that, deletes and replaces the database, for example, in production. This here is what the state might look like in the JSON file, and this is just the first 30 lines of a 2,000 line state file. But you do have to be careful because it can do things like expose database passwords. If you create an RDS instance in here to create a database like MySQL on AWS, you have to give it a username and initial password. That gets saved into the state. But the good thing is it doesn't change the password later on. So you can create a database with a password like change.me, create it through Terraform, then immediately go into the infrastructure and reset that password to like a nice 41 char string. This is really only for reference. You're never in here modifying the state. This should be read only. If you find yourself at a point where you're manually modifying the state file, good luck to you. So, now those operating modes, we actually covered this already, I think. So local state on your machine, local to remote state in the back, like a back end that can be shared amongst developers, and then Terraform Cloud. One of the nice things about the Terraform Cloud and the concept of the workspaces is I might have a workspace for my network, my VPC. That's my virtual private cloud setup. If I make a change in there, I can actually make other workspaces automatically update based on that. So a good example is, what is a good example? I actually maintain a document set up with, okay, this workspace has these dependencies based on the variables being passed in. So that's how I map, okay, the VPC has an output, which is the ID of that VPC and the security group ID. So those two IDs get passed as inputs to other work groups. Say I was creating a new security group and adding a database that needed to use that security group. My database workspace could actually be dependent on the VPC workspace. So when I modify the VPC, it triggers a downstream run as well. So I know that I've propagated that change throughout my infrastructure, and they haven't changed one thing in one spot and forgotten to change it somewhere else. We can look at some examples of that as we get through towards the demonstration part. This is what the Terraform Cloud console looks like in the middle. So basically you have an organization, which isn't shown here, but this shows 4 workspaces. So in a really basic infrastructure, you might just have dev. There's my infrastructure. Whereas this one here, I've broken this one down into my network, my data stores, my user stores, and the services that are running against those different repositories. This was actually what we had in production. Well, this is what we actually had as a development environment about a month ago when I started writing this presentation. I've changed it into 13 workspaces, so there's some lessons came out of it. It's like, okay, things were a bit too clunky with user stores. Like AWS Cognito is an Amazon product for maintaining like a user directory. Some of the changes in that are breaking changes where it actually deletes and recreates that user directory. The last thing you want to do is accidentally delete your user store in production because you were putting in your microservice into production. So there's another reason of separating different artifacts by function. And also volatility and criticalness. So some of the lessons we've learned in going through Terraform, if you're familiar with AWS, then you probably know about AWS organizations. If you're not using AWS organizations, strongly recommend that you investigate it. It does nice things like lets you have a separate billing account so that only one place is incurring charges. You can separate all of your environments, like a development environment, your staging environments, your production environments, multiple development environments for different projects, all into their own AWS account. You can put those into a hierarchy within that organization. And you're then only managing users in one location. You can either create a separate user provisioning account attached to your tree, or just manage it within the billing account. and then everyone gets to access every other AWS account that you have using roles. And it maps nicely to how Terraform wants to let you orchestrate and manage that infrastructure as well. So I have there's every AWS account still has a root user, which is like, just an email address usually. So I always lock that down with 2FA. I have a single user for myself in our billing account. And in each new account we create a role, and back in the billing account, we assign that role to the group that my user is a member of. So I, as a developer, can then assume that role and access any of the accounts. If we had a bookkeeper, for example, they would just have a role that only allowed them into the billing account, because they just need to see, update the credit card details. How much did we pay this month for AWS? If you had a team of junior developers that weren't part of the DevOps actually putting stuff through to production, they might have access to their own development environments, but not necessarily access to the production environments because of the roles. So that's, it's not Terraform, but it's a really cool thing to look at if you're not already utilizing it. What I've also found is that, I've had an explosion in the number of GitHub repositories that I have, and Terraform can plug into other providers like, GitLabs, GitHub. There's several others there I haven't used before, so you don't have to use GitHub specifically, but that's the one I'm using for this example. And you'll find that you'll start to break your infrastructure down a one-to-one between well, not quite one-to-one, but if you have a workspace, you have a repository that deals with that. So all of our network configuration for VPC is in one repository, which then translates into one workspace. The nice thing about that is when we actually go to deploy development and staging and production, we've still got one repository over in Git land managing what that configuration is, but it's associated with multiple workspaces across multiple environments. And dev might even be on a branch of that repository, whereas staging and production are on the master trunk. Like I spoke about before, a good way to separate your infrastructure is, okay, look at the foundational layers, like, okay, we have networks, we have security groups, we have some roles. Then you've got volatile stuff, which is like, okay, where are our data stores? And then there's like, code, which is like your services and things like that you're running. There'll be other, assembly things that you use, like, messaging queues, for example. So you can sort of analyze your architecture of your infrastructure and determine, okay, it makes logical sense for me to put everything associated with that public API into one repository, because we have our configuration for the API, configuration for the resolvers, all the mappings in between those, and any roles or permissions or policies that they need to adopt. And then, that all the infrastructure for that API is managed in one location, but it's running on top of other infrastructure managed by other repositories, like your network is managed external to that. So that's a good way of looking at how you break these things down. You do want to find a balance though between a flat monolithic structure, like you don't want all of your infrastructure in the single repository, but you also don't want to go crazy and say, okay, every single microservice is its own repository. And when I'm saying repository, I'm talking about the definition or the configuration. I'm talking about the actual code behind, like the Lambda function or something else that you've written up that's deployed on Docker, for example. I'm talking about just the code related to the infrastructure as code. So just the Terraform language. Again, something mentioned briefly before, if you've got a single repository that defines your network, you can actually use that across multiple environments. So the neat thing about that is, okay, we need to spin up a second development environment for another project because it's, a separate endeavor to what this other development environment over here has been useful. Let's replicate what we've got in production, create the workspaces, link them up, spin up that infrastructure, and like in a matter of hours, you've built an entire replica of production without having to, like, open that. You've only got to open the console to set your roles up to allow Terraform to do that. So calculating your CI/CD tables and all that sort of stuff is just like, use the same configuration we've already done. If we've got QA in place, security's already vetted it. We're not going to put buckets in there that are open to production. If we, things like even the PPP and the IDL loans that they're currently being done for our stimulus purposes, those banks that were putting customer applications into open buckets in the development environment because someone copied production to dev and didn't realize that the dev bucket was open to the public. So this is a good way of allowing some QA processes to, you know, overlook your architecture, have oversight of your architecture. Talked before as well already about reusable modules. So your VPC, your bucket configuration, you know, maybe there's a standard database that you start with for, you know, a T3 micro for a free database for a development project, for example. So you can create a library repository of all the different, you know, pre-approved configurations, and then you know, pull the parts in that you need and assemble those together, linking them with variables and outputs to make a new environment if it's specific to that project. So this is just some screenshots of Atom IDE. So, like, you know, we talked before about there's 4 repositories. You might have 4 projects over here inside of your repository. Sorry, inside of your IDE. And if you expanded that, you could see the data stores. Like, I used to have, like, you know, my cache in databases defined under the same module. I actually have broken that out since then, but, you know, you could have like one, you know, if you want to keep your configuration relatively straightforward, you could define all your databases in the one module. Another alternative thing you can do as well is actually have develop environment tier specific configurations within a repository. So I don't follow this anymore, but I was doing this for a while. So, for example, in development, I wasn't running multi-availability zone databases. I just had a single availability zone database, cheaper. A single NAT, cheaper. So you might have a skinnier network in there. But in production, you know, multi-AZ, yes, snapshots and backups, you know, multiple redundancies and things like that built in. So the main files in development would differ to the main files in production. With it might pull in a production version of my Elasticsearch modules versus a development environment of it. So still quite close to each other, but you can say, okay, this is the dev twist on what the infrastructure looks like versus what production looks like. And we will dive into live examples of this stuff, so it's not just death by PowerPoint. Multiple workspaces, we've probably already covered that by now. So, you know, one environment, I'm using up to 13 workspaces to manage that. And we'll jump into the Terraform Cloud and it'll make a lot more sense then as to what that means. Workspaces accept environment variables as well, so you can pass in your secrets as an environment variable. That's not in your configuration code anyway, not getting checked in. And we can trigger one activity in one workspace to propagate through other workspaces if there's changes that need to be. So here's an example of where in a data store workspace, I'm referencing my network workspace. So I'm going to import a data module here. Sorry, a data block, not a module. It's a data block saying here's some remote state. Well, that's my VPC. It's in this organization. This is the name of the workspace within that organization. And now when I'm down here defining my Elasticsearch modules and my database modules, I'm pulling in things like the subnets or the security groups or the availability zones from that external module or external workspace. So it's like propagating the resources through there. Because if I didn't do that, I could actually replace like this security group outbound ID with the actual ARN from Amazon and hard code that in there. And that might be something that you actually need to do when you're doing migration of infrastructure to Terraform, if you look at doing that. A little bit about using Git to manage some workflows if you're making infrastructure changes. Production's always running off your trunk, but in your development environments, if you are going to make an infrastructure change, create a branch, and you can make all the necessary testing and changes and stuff you need to do on that branch before you put that back into your trunk of your repository. You can set up the workspaces in Terraform Cloud to auto build, so that when it detects a change on a branch or on a trunk, it automatically does a plan for you. So if I'm working on a branch because I'm developing something that needs a new database, for example, I'm making all those database changes on the branch. Whoops, you know, forgot to change the maintenance window for the database or something, so I can make those changes, keep pushing it through. When I'm ready for that to actually go into production, and it's being coordinated with DevOps, so like actually, okay, we have now a schema that needs to be put in there. You can merge that change back onto your trunk, and a workspace in your production environment will say, oh, there's been a change. I guess Git fires a webhook off or something like that. Terraform will go and then grab that change from the trunk, bring it in, compare it to the state, and say, hey, here's a plan. It just needs you to confirm, do you or do you not want me to execute that infrastructure for you? So another thing you can do once you get those changes happening in branches is you can test things locally as well. So from the command line, you can just do a Terraform plan. And even if you haven't got the state locally because your state exists in the cloud, it will still go through all of your Terraform configuration and calculate what all the changes would need to be to implement that. So if you know that if you get a plan that successfully creates an output of like, would you like to do this? It's like, okay, my changes worked, because it's very intolerant of faults. Like if there's something that if you're trying to create a database without a security group and that database needs a security group in Amazon, it won't let you try to apply that. So you can do these changes in a branch, do them locally in the machine, and when you're really ready to say, yep, we've got the configuration for this correct, that's when you can commit to the branch and have that run in the cloud in the actual development environment. So you can do a lot of local testing on the machine beforehand. One of the things about the cloud is that you need to commit stuff to the repository in order for it to be picked up there. There's no testing stuff in there without committing to get it over there. Pardon me. And I've touched on this before, it's worth harping on, never put stuff into your configuration that is a secret, shouldn't be in. If it doesn't belong to GitHub, keep it out of your configuration, use environment variables. There's a few other best practices there, like that extends to just, secret management in general, like, using a vaulting service or a secret service for doing things like, here's an API with an embedded key in it, for example. So you put that into your secret vault, your code picks it up from there. There's examples of where we pass in the names of secrets to our workspaces as well, to try and keep as much stuff out of the code as possible. It doesn't need to be in code, or doesn't need to be, somewhere where it's susceptible to being checked into a repository. Shadow infrastructure is a problem in a number of organizations. I've certainly seen it when I was back in the corporate world. Even back when it was down to, like, people having phones that weren't issued by work. Now it's the case of who started this EC2 server in Tokyo 3 months ago. If you start using a solution like Terraform for managing infrastructure, you can, and something like AWS organizations, you can essentially prevent that unless a developer goes out and spends their own money starting up their own AWS account, putting their own credit card details into it. You can mitigate, if not prevent, people from spinning up unauthorized resources that they either, abandon and you forget about and you're being billed for, or, accidentally over provision resources and you get charged, $18 an hour for some instance that's idle 10 or 14 hours a day. So looking at taking a methodology of using AWS organizations, provisioning all infrastructure through Terraform using those roles, and basically not letting developers have administrative user accounts in those AWS accounts, only letting them have a, like a read-only account so they can go in and check their CloudWatch logs, for example, but not actually provision stuff. You can, stop the rot of, people spinning up their own resources that are abandoned and forgotten about that cost real money. I'd hate to think about what percentage of resources on Amazon are actually idle development things that have been started by someone and forgotten about it, walked away. Like, I've got an AWS bill of about $700 or $8 a month I get from about 4 years ago, and it's like I still haven't tracked down which AWS account is actually incurring this. There's probably a bucket with like photos or something in it sitting there. One day I need to track that down. So, like, I've got shadow infrastructure in my personal life. Like, what sort of shadow infrastructure does organizations accrue over time? And without doing a mass audit, how do you find that and track it down? If you've got all of your infrastructure managed through IAC in repositories, you've got all the sort of audit trails that you'd have from a code change. Who created it, when they created it, what's the commit comment as to why they were committing this particular change that resulted in something going into this environment. One of the things as well is Terraform Cloud. If you get the enterprise version, there is a Teams function there which allows you to have various levels of access in there for individuals. The free version just gives a couple of users everything, but you might have okay, developers can access dev and staging, only DevOps can access production, for example, things like that. Now, you can also destroy infrastructure through this as well. So you wouldn't want your developers to have access to destroying infrastructure in production. That's not their purview. So, not going to give this as a demonstration today, but we're going to have just a quick look at how you might create new environments. So you create your new account under AWS organizations, lock it down so no one's got access to it. We use a Titan key from Google to lock that down to the root user has to have that physical key to access that account. Create a trust relationship between them. Create roles in that new account for Terraform to utilize. Create roles in that account for a developer to utilize so they can do things like check logs. Now you've got a brand new account. Developers can only peer into it unless they're actually going through Terraform. Now, over in Terraform, then we get our configuration or a definition for a network. We deploy our network into that environment, set up any secrets and environment variables that might be needed. We create a database as that environment, change the database passwords. I deploy code artifacts from S3 buckets. So I'll create a deployment bucket over there. So any microservices I want to deploy, I'll move into that bucket. And then the last step is deploying all those services. So if I've got to put 20 Lambda files into that environment, it'll go to that S3 bucket, grab those Lambda files out of there and do all of that. And each one of these is being done in a workspace. You've got a state being maintained for all of that. The developers can still access CloudWatch to see logs and debug things if they're doing development, but they can't go and start a massive $18 an hour instance somewhere that they don't need, but someone thought would be faster to do development on, for example. So that's kind of a very brief, what does it look like to do a new environment setup. Here's an example of how actual code development might take place. So that last step was your orchestration of the infrastructure. Now, how do you actually manage stuff on top of that? And deploying code is part of your infrastructure management. So, okay, I've got to create a new function, like a new microservice. We'll make a branch in the code repository, do a development there. But over in the infrastructure land, we're going to do a branch in our infrastructure as well. So that's going to be where we define this new microservice, how it fits into our infrastructure. Developers do what they need to do with the code. They unit tested things like that. But when they want to actually deploy that, they can commit a resource definition into Terraform. And then the Terraform code gets executed and deployed. And then that goes through the process of picking up their deployable code from the S3 bucket if they've popped it into there. And it will put that microservice into the environment for them to do the testing on. They can do that, this is like an iterative process throughout development until they get to a stage where they've got code that is being accepted for use into a production environment. And that's where you start doing things like, okay, we've got all these changes on branches now. We're ready for this microservice to go into production. So we're going to merge our infrastructure branch to our infrastructure trunk. A DevOps with or an operator who's got write access to production workspaces will then take that, make sure that the artifacts are in place, ready to deploy, and they'll actually update the infrastructure. So the environment picks up the microservice, pops it into Lambda if it was a Lambda function, sets it up with the subnets that it needs access to, and all sort of in a reproducible manner. So if you've got a pattern for Lambda deployment, you can make sure that you're always using the correct subnets, you're always using the right amount of concurrency, you've always got the right memory limits and things like that set for how you'd be setting that particular service up in production. Now, getting close to the end, this is where we're going to jump over to demo mode and have a look at a few things. We're going to go through a mock exercise of migrating some existing infrastructure into Terraform for management. Because unless you are a greenfields enterprise, you're normally not building entire infrastructures from scratch. You've got a legacy infrastructure that's currently in use, and you might want to say, okay, we need to stop managing this by hand. We want to start managing this through Terraform. So I'm going to change screen sharing. I'll talk to this for a moment, but I'll change screen sharing and I'll actually go through this example and show what it might look like. So really what we're going to be doing is setting up a new repository that exists. We're going to create a provider for AWS locally. We're going to create a empty definition locally. We're going to match that empty definition up to an existing resource, which in this case we've got an S3 bucket and we've got an RDS MySQL instance. We're going to import those into our state, and then we're going to update our definitions to match what's actually in production, and then that'll give us completed configurations for those resources and a valid state for those resources. So then if we wanted to make changes, we could then start making those changes from Terraform instead of jumping off over into the RDS console or the bucket console to do that. So I'm going to change screens and have a quick look at GitHub. And of course, I've closed GitHub. So can everybody see the GitHub screen there? Nope, okay, must be sharing it online.
There we go.
Okay, you can see it. Okay. So yeah, we've got a ton of repositories over here nowadays. I just use a TF prefix to designate. Okay, this is my repository for managing my virtual private cloud in Terraform. So I've got a repository set up for Southwest Florida coders with just a few things in there. When you are creating a new Git repository, one of the things you can do is, just to demonstrate it, unfortunately, the Zoom windows were blocking this. So when you do a new repository, when you go down, you're selecting whether it's private, whether you want to initialize it with a README. You can pre-populate with a GitHub for Git ignore for Terraform. So Git is aware of Terraform as a solution, and you can create a new empty repository with a Git ignore there for Terraform that's going to have all the things like, ignore your states, ignore your variable files, anything you shouldn't be committing into that repository. Now I'm going to change windows again because I have this created already. So creating a new one, trying to populate it. You share. Okay, so we should be seeing an Atom screen right now. Good. Okay, so this here is the that repository we've already imported that previously. So we have a look in there. We've got a provider. That provider pulls in various credentials, which would be just like a little TF vars file for Terraform variables. The live one's there. I won't click on that. So this is where you define your access key, your secret key, your Terraform role. Git ignore would say, hey, don't check these in. So we've got a provider set up. We've got the credential set up. And we've got a variable set up saying the same 4 things that were in that variables file. So when Terraform runs, it knows to expect a region, an access key, secret key, and the role ARN of what will be being used. So now I need to share, there's a little bit of jumping around here, unfortunately. Going to go to the terminal. Oh, sorry, just scroll. Couldn't find it for a moment. So this here, I'm just on my hard drive. I'm in the directory for this particular project. And the first thing we're going to do, because this is brand new, all I've done is created a provider file, I've created my variables. I'm going to do a Terraform init. And it's going to search in this directory for any Terraform files, see if there's a new provider there that doesn't have, and if there's a new provider, it's going to download the plugin for that. So this is like basically grabbing the module from Terraform that lets Terraform talk to the AWS API for managing AWS infrastructure. This usually takes about 10-15 seconds. There we go, successfully initialized. So now we can have a look at, if we did a Terraform plan, for example, we haven't imported anything, and we've only got some empty stubs in there. So this will throw errors. But normally what you could do is plan your infrastructure. So screen sharing sucks when you have to change windows. I'm sorry about this. I'm going to jump back. So we're going to have a look at the back over here in the project. So we should have Atom back on the screen again. First thing we want to do is import a database. So I've created a Terraform definition file for RDS, Amazon's database service, and it's literally empty. It's a resource block saying it's AWS database instance, and this is the name that we're going to give the block. There's no attributes defined there whatsoever for it. So we're going to use this stub to import an existing database that exists over on AWS. So if I was to go to AWS right now, more jumping around than I expected was going to be involved. Maybe open the, sorry, I'm getting there, guys. Gals. And look at the Chrome. Okay, so now can we see my Chrome GitHub? Can we see AWS now?
Yep.
Great. Okay. So we're over here in AWS. Over in our dashboard, we have one database instance over here. So we just got a little database called SWFL Coders. It's just a little T2 micro free MySQL. But we want to import that. So what's the name of our database? SWFL Coders. So we will, in screens again, we'll go off to our terminal, and we're now going to import this resource into our local state. Oops, here we go. So the command to do that is a Terraform import command. The resource type is an AWS DB instance, which matches our definition block. SWFL Coders is just the name we gave that block in our definition, and it just happens to match what the database name is itself over in AWS land. And if I run that, fingers crossed, it's now going off and basically went over, interrogated AWS through the provider API, found that database, brought all the configuration of that database over into the state, and that state is now local on this machine, replicating the configuration of that database. So we're now going to jump back over to Atom. We now have a state file available. We open that state file up. Here is a database instance, the SWFL Coders. Here's all the details about it, the address, how much storage is allocated, availability zones, retention windows, domains, delete protection, false, not good. So all of that has been brought over through that provider API. So that is now a local file on my local machine representing the actual state of that database in AWS. Back to the terminal, get faster changing. If we were to now do a Terraform plan again, it's going to be comparing that little empty resource stub that we had with that state. It doesn't match. None of those resources attributes are present in that stub. So we can't plan it. We know that, okay, we've imported it, but we haven't replicated that configuration yet. Luckily, did some planning beforehand. So here's our empty stub. This here is what the populated resource would look like. If we rename this Terraform definition and then did that planning again, this here is the basic minimum information that we need for Terraform to say, yep, we can now determine if there's any differences. So we'll just do a quick rename here. So .stub, we'll rename the populated one to just a definition file. Now, when we run Terraform plan, it's going to be comparing this resource block to the state, because I've gone through and set this up earlier. What you'd otherwise be doing is you'd actually be opening that state file up and transcribing the minimum required attributes from the state file into your resource block so that you know that you could then manage. Back over onto our terminal, we're now going to do a plan again. It's comparing the local resource block to the local state. And it's actually saying that we have one to change. I think it's picked up the S3 bucket. Yeah, there's an S3 bucket as well. So I have a stub there to import an S3 bucket next. That doesn't appear in the state yet because we haven't imported it. So Terraform thinks that we need to actually go off and create that, which we're not going to do. We've only planned this change. And if we look at the database, it's actually saying the database needs to be modified because of the password being hard-coded into the definition file. If we run that once, that change request will go away. So what we're going to do is, without jumping over, I'm going to quickly do the same thing for S3. We have a S3 stub. So if I was to try and import that right now. So I have a bucket called SWFL coders, and SWFL coders.rumple.io is the identifier for that bucket, globally unique. I can import that. I've imported my bucket to the state, so now the local state knows about my database, knows about my S3 bucket. If I plan, it's probably not going to. Yeah, it still thinks there's a whole bunch of things here that are now missing from this bucket definition. But it's picked up our cause rules from AWS, basically the privacy settings in the buckets. Because my local stub doesn't have those defined yet, it says, well, if you run this plan right now, I'm going to go and destroy all that privacy stuff over in AWS. So the way around that, of course, is to bring in the previously supplied configuration that I've created. So over here is now, instead of having the stub resource for S3, I've got a populated one. I've got my cause rules defined, I've got the ACL set, false destroy false. So I set a tag on it for the demonstration. I'll rename this to make it part of the what's available. Go back over to the command prompt. We'll try that plan again. And now it shouldn't want to be changed in that bucket. It'll only want to be changed to the database. And only because of that password. It's a, no, it still says it wants to change it. Okay. I've illustrated the principle. Basically, you import you create a stub, you import your infrastructure, you update your local stubs to match the state that you've imported, and we now have a state file locally that would allow us to manage these. So, for example, if I want to change, I don't know, if I wanted to add a tag, for example, from demo true to demo false, I could change that tag there, apply this plan. And to do that locally, instead of a Terraform plan, you can do a Terraform apply, which essentially does that planning step again, and then gives you the opportunity to actually execute that plan if you wanted to. And I do not right now. So back to the presentation for a moment. That's the process that you would go through if you were looking at importing existing infrastructure. But all we've done is brought it onto my local machine. That doesn't let the guy next to me or someone in the DevOps team manage that infrastructure. It's just allowed us to import the state of it. As you can see, though, it's a bit of a tedious process. You import things piecemeal. It's incremental. It takes a while to do it. A piece of functionality Terraform has under development, they've been talking about for a while but haven't released yet, is actually the ability to import an entire infrastructure and create those definition files for you. So rather than just importing the state, it's like, okay, we can go off and we can get the state. That's easy. That's already existing functionality. We'll get that state, and from that state, we'll generate all of those definitions and configurations for you. That will be a game changer in terms of, like, you know, being able to migrate to a Terraform platform. At the moment, you've seen how manual it is and incremental. They're promising that, you know, click of a button type stuff, they'll let you generate all of the stuff that you just need to check into GitHub to manage it moving forward. I'd imagine one of the things that's slowing the rollout of that out is how do you manage taking that and refactoring it into meaningful related modules and things like that. It'd be easy to generate a big, huge flat mono repository, but you want to be a little smarter than that, I think. Once you've got a state matching infrastructure, you can't really refactor the definitions and code in terms of, like, reorganize them into different hierarchies, because it breaks the relationship between your definitions and the state. Learned that the hard way, that one. Don't reorganize your modules after you've put it into use. So that's how you migrate your infrastructure into Terraform. Now, how do you manage that so that a team can look after it? So this is the second part of the demonstration. Okay, we've now got a state locally. How do we get that over into, say, Terraform Cloud, where multiple users can access that and utilize it? And we can apply our workflows and set our triggers up in relationships between workspaces. So in order to migrate from your local to Terraform Cloud, you've got to go through and clean up any local environment variable references. So when we saw we had the references to the secret and the region and the access keys, take those out. Commit those changes to the repository, because anything you want in the cloud has to be in the repository. We create a backend block, which is like a one-time use to migration definition to say, hey, this is my organization. This is the workspace I want to be created. You log into Terraform locally if you haven't already done that. I've already got the key locally on my machine. And then the Terraform init command will, this time will say, oh, you've got a reference to a new remote backend. I'm going to migrate the state off your local machine and put it into that backend, create your workspace for you. And then we'll switch over into the Terraform Cloud interface, and we'll see this new workspace that's been created for us as part of this exercise. So jump back over into Atom for a moment. So back over here in Atom. Sorry, I've got three screens, move the mouse across. So here I have a migrate block previously defined. I'm now going to enable that by getting rid of the thing. So I've got an organization over in Terraform Cloud that exists already, Southwest Florida Coders, June 20. I want to call this the workspace. I could call it anything. I could call it Coders Today, for example. When I run this process, it's going to go and create this new workspace in this existing organization that already lives over there. So we need to jump into committing our stuff to the repository. So I use source tree, managing that locally. I'm in my source. I'm in my workspace here. I have got. I want to commit my new definition for the database. Commit my definition for the bucket. And I do not want to commit this migrate block because it's only a one-time use. So I'll stage those and say new infrastructure imported or something. I'm going to push those changes. Okay. Obviously the files have got the the extensions there we don't care about. We don't need to check our migrate blocking. It's only used once locally on a machine to facilitate this process. If we would pop over now to, let's have a look in Terraform Cloud before we do this. So get out of AWS, we'll go to Terraform. So I've got a couple of organizations over here. This, for example, is my development environment. So you can see I've actually got the VPC set up, got a little messaging queue set up, IAM roles are set up. got a few different GraphQL API endpoints, so each of those is self-contained with all their stuff. Got Elasticase, we've got a bucket that we deploy from this databases, there's user stores. This is how I've broken this environment down, and they all tie back to what's the specific repository over in GitHub that manages this for you. So if I look at the VPC, for example, I can see the runs, I can see all the different commits that I've done, whether it was succeeded or failed or cancelled or just planned with no changes. And I can even see the states behind that. So all the states are in there, what are the changes. For the purposes of our demonstration though, I've created a separate organization. So I can have multiple organizations. You might use your organizations, for example, to manage, so unlike AWS, you have one organization. In Terraform, you might have multiple ones. You might have one that references your production environment, one for your development environment, one for a specific project, for example, and the workspaces sit within that. Now, as you can see, within this particular organization, Southwest Florida Coders, June 20, we don't have any active workspaces yet. We're going to create one by exporting our state. So we'll go back to our terminal. And within this terminal, we've now created, remember, that migrate block. So now if I do a Terraform init, because I'm already logged in, here's a live demo, fingers crossed. It's found that there's a new backend, which was in that migrate block. Asked if we want to copy our existing state to that new backend, and the answer to that is yes. That quickly, we should now have a workspace in. Ta-da! Here's organization. Here's Terraform Cloud. We now have a Southwest Florida Coders Today workspace. If I open that, there's the state that we've imported. That's the same state that exists on my local machine. It's now sitting in the cloud. However, in order to now manage infrastructure from here, we need to do a little bit of setup stuff. For example, we need to set up those same variables that we removed from our provider. We need to set them up in here. So, for example, one of those variables was Terraform ARN. And I can grab that from my bars and bring that over, and I can save that variable. I can also add some environment variables. So I usually use, I'm actually going to quickly cheat and just look at the formatting I use for these to make sure that I don't screw them up. So yes, default region, my access key, which I'll be changing after this presentation, and my secret key. So I'll just grab these from here, I'll transcribe those in, and then we'll be able to actually start using the cloud interface for managing that database. So back to our new workspace, setting up the variables. This is one thing I do wish that they'd let you, use another workspace as a template for, so you didn't have to, especially when you got 13 of the bloody things. You can't get away with, copying this whenever you have to literally cut and paste them each time. And now this is actually quite sensitive, so I can actually flag it as sensitive. So coming back to like your management processes, like you don't necessarily want a team of junior developers having access to the secret access key to get into the Amazon accounts that might let them bypass and start creating some of that shadow infrastructure. So yeah, I need to change screens for just a moment because I really don't want to reveal my secret key in a Zoom call. So we'll jump back to that while I do this in the background. Hopefully no one's seeing my secret key. Now if we come back here to, we can see that secret key is actually hidden. If you go to edit it, you can't see the value of it. It's hidden from the user. So you might have a team, you might have a developer in the team, you give them access to this workspace. They can set all the variables, but they can't see that secret key because it's just so damn sensitive, because you can only ever have 2 active secret keys in your organization at once. So we've got a workspace, we've got a state. Now we need to link it to version control so that we can now commit changes to Git and they will be available to this immediately. So I'm going to connect to GitHub. Sorry, there might be a big blank thing on the screen. Okay, so now that I've linked that to GitHub, I can now go through and I can choose which repository I want to connect to. There. Now, if I was doing development, I could actually link to a specific branch within that repository, as the default is just a trunk. And I can say to, maybe I only want to trigger changes when something changes in a specific path of that branch. So this isn't continually doing triggered things, but we'll just let it run, always trigger runs. And if there was additional workspaces here that were dependent on it, you could create a run trigger so that when I don't have any other workspaces, but when this workspace updates, trigger a change in that workspace to propagate things. Unfortunately, you are sort of at the point where we might have to stop looking at this particular thing because we're now waiting for Terraform to get around to pulling this job off the queue and linking our repository up. And they've just done that. So if we now have a ready-to-use workspace in Terraform, I can queue the plan, which is like doing Terraform plan. Can be a little bit slow. Follow the log. It's now going through a planning exercise, and said that we had errors. And the reason for that is that I've actually checked in a variable file that is no longer needed because we have local variables. So what I can do is go to, I'll go to my repositories, remove the errant file. I no longer need this file here. The quickest thing to do actually is for me to just delete that and change and check in the deletion of that file through source control. So I'll just leave it there for a moment. So I'm removing that variables file. Let me quickly commit that. Oops. Now, I'm about to click commit. We'll jump back quickly to over here. So at the moment, I've got a status of errored. Because I've made a commit to GitHub in the background, if I refresh this, it's auto-triggered. So GitHub has reached out through a webhook to Terraform and said, hey, there's been a change. I can now go in and I need to change my provider and just remove the unnecessary things from there. That's because I had a we remember in the presentation, I had a picture of 2 different providers, one with access keys populated, one without. I need to that change as well. So, live demos never go smooth. So I'm making another commit in the background. I'm back over here in my workspaces. It's being queued, it's pending. Maybe this time it will commit for us. So this is one of the things that, yeah, I know exactly what I've done. See if we can get it right this time. I removed the entire file. I should have just left that one variable in there. So I'll jump over for a moment to explain exactly what's happened. In Atom, I had, can everyone see Atom at the moment? I'd removed this Terraform role ARN from the variables which I declared, and we create that in the workspace as here's a file that's needed. Here's a variable input to expect. So that's the thing. Terraform is very fragile when it comes to if you. So we'll jump back over to Terraform Cloud again and see how it's going this time around. So it's already picked up that change because I've committed to GitHub. This is the way I do things on a branch, by the way. There we go. We're good now. So it's we're over here in Terraform Cloud. We've imported a couple of resources into our state. We've migrated our state to the cloud, and now if we were to make changes over here, so it's going to do things like, it's going to add a force destroy attribute. It's going to add an actual attribute to the bucket. It's going to change the password on the database. It's now saying that it is, needs confirmation. So I can come in here, I can confirm this, put a comment if you want to. Although what it does is actually picks up the update was the comment that I put into GitHub, so it always picks up the check-in comment, the commit comment. And now it'll queue that change and go off and execute it. And so that's a successful file. But moving forward, if you had to create additional resources, if you had to make database changes, you might want to provision new EC2 instances, create the definitions, commit those to that same repository, and you'd come back into Terraform Cloud, and the webhook from GitHub would have triggered Terraform Cloud to do a planning run, and that'll be sitting there with either an error, planned, like no action needed, or needs commitment, like it needs confirmation, like you've made a change, we've picked it up off the particular branch we're following, and we're ready to actually execute that. I don't know, I might not have had immediate changes for RDS. I'm going to leave that there for a bit. What I would like to do now, though, just to wrap up, is just have a look at what our real Terraform configurations look like. Some of the big stuff. So these are the workspaces that we have for our current dev environment. We can actually go over and have a poke around in some of those live definitions of how we might have stuff set up. Because there's some things like, one of the things you might be familiar with AWS is like there's roles to manage. So you can use Herodot or things like that. But there's a few ways of managing it. So if we go to, for example, a GraphQL configuration. Can everyone see the Atom browser? Are we looking at the right spot? Yes, no? Are we looking at Atom at the moment?
Yes, we're looking at Atom.
Okay, thank you. So GraphQL Public is a little GraphQL API that manages contact forms on our live website. So if I was to go back to Chrome for a moment, so if we go to Rumple.io, this is a little Gatsby site that we've got at the moment, and it's quite simple. It's just a placeholder. And if I click the Join Now button, so Gatsby is a static site, but if I click Join Now, it actually brings up a little pop-up, and I can submit my email through there. That's actually integrated with Apollo GraphQL, and it's dynamic, that part of the Gatsby site. So there's a little GraphQL API sitting behind that to manage that integration. So there's a single Lambda function that was quite simple. And are we back on we're back on Atom now? We can see Atom. Yes. No?
Yes.
Yeah, great for you. Yeah, just a lot of. I've got 3 screens and a bunch of windows moving around. So this repository over here is how I manage that microservice that manages our, email scraping form. So I have a main form here. I've got a local variable setup, which is like just what's the name of the repository, because I like to pass that through all my resources as a tag. So if I am poking around in Amazon console, I can see that, oh, this microservice is managed in the TF GraphQL public repository, just to sort of trace it back. I've got some dependencies on other workspaces. So my deployment workspace, which is where I upload the zip file of the Lambda to. I am workspace, which controls some access roles. Messaging, because I actually have a bunch of queues in there. So if I have a failure on the back end, I pop a message onto an SQS queue, which actually goes off and gets handled by another microservice in another workspace, which actually tells me in Slack that, hey, you've had a real-time failure. And the VPC I need to get things from. So these are all the workspaces I need to take an output from as an input for managing this little GraphQL. And there's only two modules inside of here. One is the Lambda microservice for managing the form, and the other one is the AppSync, which is AWS's GraphQL tool for managing the schema and the resolver mappings between those. So Lambda. So we've got our main file. We're going to import our Lambda module. So source modules Lambda, modules Lambda. We're going to pass in the IAM role that allows Lambda to execute. We're going to pass in our messaging queue ID for the queue if we have an error that we put the error message onto. The local repository, which is the value from the top, so that when we create our microservice in Amazon, it's being tagged with the TF GraphQL public. The deployment bucket to reach into and pull our artifact from, and then just some VPC information that's required, like the ID, the subnets, the security group, for that microservice to actually deploy. Same thing up here for AppSync, but just to have a look inside of Lambda, going to Lambda, variables. So this file says, okay, these are all the variables I'm expecting to receive into this module from this calling one, and they map to all of these variables. Here's the outputs, because I need that ARN for something over in my AppSync module. And this here is a live configuration of what this particular microservice is. So some data, we say, okay, here's the name of our deployment bucket. Here's the path to that artifact inside of that bucket. So form.zip is the deployable Lambda compiled Go file to be deployed. I'm declaring an AWS Lambda function resource, which is the form. Here's the bucket you can grab it from, the keys and things like that. Uses versioning, so I can see inside that bucket and say, hey, has this changed? Is it the old file? If it isn't, when we do a plan, we leave it alone. Oh, the hash of this file's changed, so, or actually the object version has changed, so we need to redeploy this resource and replace it. Pass some variables through that show up as a Lambda variable. Put our tags on there. So I always tag a resource whether it's being managed by Terraform, tag it with a repository. And my Lambda functions are always tagged with whether it's a resolver, a queue processor, a scheduled one, for example. Give it the role, give it some set settings here, the VPC. So when this configuration is applied for the first time, it's going to reach into S3, grab that zip file, put it into Lambda with all this configuration here. I can then rerun this if I wanted to and change the timeout to 20 seconds if there was like a delay on the queue or something like that, for example. I'd never go into the Lambda console to do anything related to this particular microservice, except go to CloudWatch and look at the logs. So you're no longer having to go in and manually grab a zip file off your drive somewhere and manually set up this stuff. This is like the minimum set of stuff that's needed. There's implied defaults, like I don't have any concurrency limits set on this particular one. And I think the last thing to look at would be, just to get close to wrapping up here. Sorry, I'm trying to find Chrome again. Here we go. If we actually went over into the Terraform documentation, we can see here the documentation for that particular resource. Gives basic examples of it. You have set up all the CloudWatch for logging, and then down here's the argument references in terms of all the stuff that's optional, required. There's a lot of stuff, you know, if you're setting up dead letter queues, things like that. And then there's like all the possible, there's outputs as well. So yeah, really good documentation. It's quite comprehensive. And yeah, you're going to do things like, you know, manage the specific roles, policies that are needed for that to execute. Yeah, so pretty much at the end of what I wanted to cover, I think, in terms of showing. Yep, that was it. That
was really good,
is
Ben. Thank you
an
so
intro
much.
to Terraform. It's a huge, massive data dump. So thank you for sticking with it.
Thank you, Ben.
That's okay. I'll let you take control back here as well.
I think, does anyone have any questions? I think there was a question that Daniel asked, but I think Greg already answered it. But anyone else have a question?
I've got a couple comments, but I'll wait for people to ask questions first. I guess no questions.
Jump in.
Okay. My experience with Terraform is varied. I'm pretty much dealt with it, not with Terraform Cloud. So that was new to me. And that was great to see. Some of the things that, for anybody who's not familiar with Terraform, understand that it is a declarative language and it is not procedural like C++ or whatever. You don't tell it step by step by step. That a language that comes close to it is sort of like Ansible, where even though you declare what you want done, you do have to give it a order of steps. Terraform will figure out exactly what it needs to do most of the time.
Most.
Okay. Yep. There's the famous depends upon clause for
yes.
things, and
right before destroy.
right, and
yeah.
Yeah, perfect. Also, with variables, you failed to mention, you pointed out locals and variables, but variables are static, so you can't take a function and assign it to a variable. That has to be done in a local. It's one of those little idiosyncrasies of Terraform. Workspaces, even on the command line, is very interesting to, would be very interesting to show. I use that, and I set up, the first thing I do is I go in and I do Terraform workspace, new, dev, QA, prod.
Yep.
And you can actually suck in the workspace name and drop those into your code. Now, there's another caveat that I do want to let everybody know, okay? The difference between Terraform 11 and Terraform 12 was like a tectonic shift. So you're going to be going out in the internet and finding some old code. It ain't going to work very well. So there's a lot of refactoring you're going to have to do with some of that.
Yes, actually, I started on about Terraform 10.
Yeah.
And
I did
went
9.
through 11, no problem. Went to 12. 12 was actually the trigger for me to start looking at moving to Terraform Cloud, because like everything I built before that was like so much of it needed to be refactored, all those configuration files. So
Right.
It's just one big breaking change they did.
The import function, I've never done that the way you did. That I've actually had to import several environments, and originally I was using a little open source product called Terraforming by DTAN4. He kind of stopped production on that and support, and now there's a product which I put into the chat screen called Terracognita, which is really good because you can actually just point it at the environment and it will suck down everything in the account and drop it into each type of service.
Yep.
Okay.
A quick question there. Have you used TerraGrunt? Because there are a few tools that have been built around the Terraform.
I've looked at it. I haven't used it. I mean,
me either. So I was hoping you might have something to add. But yeah, there's an ecosystem of tools evolving around Terraform by other third parties as well. Like it's taken on a life of its own.
Now, anybody who really wants to learn Terraform, I'll give you a great resource. Make no money off this. There's a guy on Udemy called Edward Vienne. Actually, I'll call it up and I'll put it in the chat. He's actually has 2 courses on Terraform, one for AWS and one oriented to Azure, which really makes it a lot easier because it's focused on some of the idiosyncrasies of both environments. So that's another thing. And also Terraform registry, perfect place to go looking for code, finding it. You can pull down a module that builds you a whole VPC and you've only coded this much.
Yeah, I didn't show it. I actually use that for my VPCs. I thought it probably was a little confusing to do that, but I do have an example of that. So this is like I'm not sure if Amazon provided it or whether it's just something that's come out of the open source community that's been built by other people. But I think if it's the right one, I'll just quickly share my screen again.
I think this needs to be the last thing. Then we have to move on to surveys.
Yep. Yeah, so there's here using a third-party VPC module. You just provide the attributes to it, and it goes off. It builds the subnets, it builds the NAT gateways, it builds your internet gateways, all the endpoints that you might possibly use in a single definition block, as opposed to creating 80 different little resource definitions to do all of that, like bespoke. So cool. And any other questions for either of us? Oh, cool. Okay. Well, thank you, everyone.
I got a quick question. Just in addition to that Udemy video, is there what was your pathway to learning besides videos? Did you just dive into the docs?
No. Actually, the way I did it was I literally took Edward's course, and then I started nosing around in Terraform registry, finding the actual GitHub repositories, seeing how other people did it, stole code like crazy.
Okay.
But I mean, there's plenty of different snippets on different ways, and you go, damn, I never thought of even doing it with the product this way. So that is like a gold mine right there. I mean, you can just easily go in, grab a module and say, okay, build my VPC, and it's a black box. Or you can go in and dive into the weeds and really see a lot of the code and go, and it gets you thinking.
Okay.
So, also,
that was the same for you?
No, so my pathway was basically finding a example in a blog and just following like someone's tutorial that they'd done that way, and then I built so much stuff in Amazon. It was like, okay, how do I start rebuilding all this stuff myself? And unfortunately, that put the blinkers on me a little bit because I went down this path of doing it all locally with a local state, and I missed a bunch of other stuff. It's actually during the course of preparing for tonight, which I really realized it's gone quite a long time, but I hope it was of value, that I learned about a few other things to add into this actually. So, but yeah, I just found I got Googled IAC, came across Terraform versus CloudFormation type debates, thought I'd check out Terraform, followed a tutorial on it, and then started building up, reproducing my infrastructure. And I would never go back to doing it by hand again. It's like Terraform, like IAC is the way to go from now until I'm 80. So until something better comes along.
All right, thanks.
Okay. Oh.
If we have time.
Yeah, go ahead. Who was that?
Sorry. Yes, Daniel.
Oh, then. Okay.
Question about the security. I know you mentioned it, but I'm not sure if I understood it correctly. Is there a utility inside of this platform that allows you to scan or identify if something accidentally was disclosed, like an access key or a secret of any sort?
Well, I'll jump in. I'm not aware of anything there. Like you could certainly peruse your state file, because that's available to you. You can download that, and you could, just control F it for your secret keys and things like that. Because I think that's there's two places you can get exposed. You can expose stuff if you put it into a repository, like you commit your definition with a secret, or if you execute, like you saw, the database was trying to put the database password into the state, which is why my database passwords always start as change me. But yeah, I don't have any tooling that would allow you to scan for that, other than being aware of, okay, these are the pain points of where you might have a breach of a secret, and being aware of, using environment variables, marking them as sensitive, using your git ignore file correctly. But yeah, in terms of otherwise, you'd have to come with an audit process for examining that stuff.
Got it. Thank you.
Alrighty. Well, just so you guys know, Ben is on Slack. I think he works from home, right? And he's like,
technically I work from this office, but I'm not supposed to be here.
Yeah, we all pretty much live on Slack, so if you guys have more questions, you guys are always free to reach out.
Normally from home.
Ben is always pretty awesome about answering questions. Now we're gonna go to the raffle. So we have two things, Derek, right? Do you want to share your screen to run your code, your script? You're mute.
All right. Didn't hear that?
Hello?
Okay, cool. So we have the book and we have the license. For the book, just so you guys know, I'm gonna post the link in there. The link, this book was donated by Daniel from the podcast that he had. And what is that? Is that
It's whiteboard. I've never seen that before. I had to try it out.
Oh, that's cool. And wait, before I forget, so Daniel, we're gonna raffle that book, but also the author of the book was very kind to offer him a 40% discount. So I also gonna put the redemption code on the chat. So Derek, all yours.
All right, cool. Can everyone see my screen? What are we raffling off right now?
Let's do the book first, I guess.
Book? Okay. Well, it's not going to say book, but we'll just say it's the book.
Okay.
All right. Here we go.
And the coupon code is going to be for, if anybody else that doesn't get the book wants it, it's right there.
There you go. Matthew? That's how you pronounce it, right?
Yeah, that's fine. Thank you.
Congrats.
I feel bad. I just joined like 20 minutes ago, only to get the end of the whole talk. But thanks.
Sure thing. No worries.
Matthew, are you on Slack? No, right?
I'm not on Slack. I'm very new to your community. I only got the link from Reddit and then joined from the meetup group. And
awesome.
That's about the little contact I had with you guys.
Well, glad you found us. So if you want, you can send on a private your email to Derek. Oh, no, wait, to Daniel, actually. Daniel, you're the one that has the book, right?
You can message me on Slack and I'll give you the code.
So he's not on our Slack yet.
So you can send me an email if you want. I'll put my email here on the.
I can stick around and we can do the finer details towards the end of the whole thing.
Sure.
Does that sound cool? Because I don't know where the Slack is, nor its name. I know nothing.
No worries.
No problem.
Okay.
All right, cool. Here we go. This is for the JetBrains license. It'd be crazy if it was Matt.